So one of the requirements at many airports is to utilize what's called an ILS system, instrument landing system. So if the pilot doesn't have visibility of the runway, there's an instrument landing system which is all driven by RF communications between the airfield and the plane to make sure the plane gets into the right glide path and can land safely. And of course, the airport has a obligation driven by standards and what have you, to make sure that the RF spectrum is clear. There's no source of interference against the ILS system. And that's exactly what we're going to look at here with the RFeye system. We're going to be zoomed into a specific area into the spectrum where the ILS is operating. There's also various other push-to-talk walkie-talkie systems, radio cabs, different channels operating in the area. And what we're going to do is show how the monitoring occurs, and we make sure that there's no signal interference. And if there is some interference, we can actually track down the source of that. So what we do to begin with is we're recording data over the frequency range of interest. Here it's from 118 to 122 megahertz with very high resolution on the RFeye node. And we record data over a function of time. This example is only really 1 minute. The reality is it's recorded over a number of days. And what we do is we set user-defined thresholds. I've actually set those thresholds very low here for the purpose of the demonstration, so we can actually see the different channels being captured and recorded. But these are set according to the definition of the CAP670 regulation. So what we'll do is we'll see individual spectrum over time, showing different voice data channels coming. And what we'll see is as that bursts through the mask, we'll see IQ detection. And we'll also see how we do a decode, and we look at the voice of the data channel that's there. So let's run. It's running. What you've got there is a threshold break. What you see is when the break happens, and you'll see a few of these as we go through this example, you'll see the burst of IQ capture that's happening. You'll see a Fourier transform of that, and at the top you're going to see the audio waveform. In the live system, you can also replay back the voice channel. So you can see very clearly there a voice waveform going through. And as these different push-to-talk walkie-talkie channels between ground crew and aircraft or ground crew and operations, as these different channels are triggered, you see the voice, and you can actually hear the voice in the live system. So the idea in reality is you set your RFeye node up onto the airfield, you set up your thresholds, etc. as you see fit, and then you leave the system autonomously recording that data. And when you come back at the end of the test period, you basically have a complete list of any threshold breaks, time-stamped, frequency, and also we've performed an IQ capture of each one of those channels, and we're able to go back forensically and determine whether that's a voice channel, a data channel, and obviously go and make the appropriate adjustments if that's causing interference. Interesting application for the RFeye system. Cheers.